This slideshow is on how I moved this shed by myself. Moving any shed is hard. There is no easy way. The shed is on the site of my future workshop. There's lots of trees to come down. My plan is to use the lumber cut from these trees for planking for the attic flooring and the roof sheathing. The shed is 12 feet by 12 feet by 10 feet tall. This slide shows how I removed trees so the shed could be relocated. I have a log arch which is towed behind the garden tractor, and for the longer logs I used an additional wheeled axle. This log was cut into 16-foot long 1x8s, and the distant logs, the smaller ones in the background, I used for cribbing for the actual shed move. And since I have my own sawmill, I could cut any size cribbing I wanted, and so I maximized the use of the lesser value logs and cut 4, 5, 6, and 7-inch cribbing. This is my new toy, a Wood-Mizer sawmill. This is the largest piece of heavy equipment I used regarding the actual shed move. This shows some 1x8s cut from a medium-sized tree. I hope to get 1x10s and 1x12s from the larger trees. I've standardized on 16.5-foot lengths to make stacking and drying easier. As previously mentioned, treetops not big enough or straight enough for standard lumber are used for the cribbing beams for the shed move. Here a 12-foot long 6x6 is being moved to the new shed location. The shed is braced inside and out with scrap lumber. Here is the inside bracing to stiffen the shed for any possible stresses due to the moving. These tree stumps were cut low so the shed would pass over, and cutting these stumps so low to the ground did not help my chainsaw blade. I had to resharpen it twice to get through them all. Here I jacked up the shed to get the 6x6 skidder beams underneath the shed. Here's a view of the skidway which will guide the shed to its new home. It's all staked and screwed together to immobilize it. The block piers have already been set. They're all at the correct locations and leveled, and they're all setting on solid subsoil. And the sideboards on the side of the skidway to keep it lined up to get it pretty close to its final location. You can see here that the shed must rotate first before it can line up with the skidway. Here I'm jacking up the beams to get the shed up high enough to get log rollers in place underneath it to start the rotation. And you can notice that the skidder beams are attached to the shed with some anchor ties and some scrap lumber to keep the shed from moving around on top of the skidder beams. To find the optimum roller placement to get the shed to rotate in place, I practiced with this wooden model to find the optimum roller positioning. Here the shed is starting its rotation. Tow straps, chains, and come-alongs can move almost anything. The opposite corner of the shed is prevented from moving by another come-along and chains so that the shed can turn sideways. The cable attach points were the weak spot of my process. I didn't want to make a special trip to the hardware store, so I used metal strapping I had on hand. This attachment point broke twice. I finally doubled up the broken pieces. I was worried that on the downhill section the shed would roll ahead too far, so I put in this rear side safety rope. There was too much resistance of the rollers in the soft ground and friction in the skidway for that to occur in practice. This is a view of the rollers compressing the dirt. The shed is now turned. Here I'm lining up the shed to the skidway. Here I'm using 2 sets of straps and come-alongs, jiggling it back and forth to keep it centered. The trailing edge of the shed wasn't lined up to the skidway, so here I had to pull it sideways to get it lined up. It didn't slide sideways very easily, so I had to use the lever and fulcrum, as you can see, to give it a little extra oomph to shift it over. Fortunately, there was always a tree nearby to use in redirecting the shed into whatever direction I needed it to go. Here I had to do some extra jacking to prevent the shed from nosediving and getting stuck onto the skidway. Here the shed is all rotated and lined up on the skidway for its final move. Here again, as you can see, there were lots of trees to pick from for anchoring the cable pulling to get the shed to move where I wanted it to go. It's almost home. Another little sideways pull to get it lined up. It is now at its new location over its piers. Another view after the move, showing the shed sitting on top of its cribbing. Here you can see the from and to locations of the shed move. Here I'm jacking up the shed to pull out the cribbing. There's another view of jacking up the shed so I can get the cribbing out. The cribbing is all removed. The shed is now sitting on its piers. The next step is to lower it down. I found out the shed needed to be stabilized during the lowering process. If one corner is lowered too much at a time, the shed tilts and tips the taller piers and moves itself out of position. I added this strap to hold the shed in position. Even as it was, I had to move the front blocks to where the shed is shifted to. Here I'm lowering each corner 1 inch at a time. The shed is now settled into its new home on its piers. In this view, you can see the sagging floor, which will have to be addressed in the future. Here the skid beams have been pulled out and turned over to show the aluminum flashing, which was intended to reduce friction between the rough cut beams and cribbing, but there was still a lot of drag to overcome. Wood that was not in the sunlight or rain is in pretty good shape. The estimated age of this shed is about 40 years old. It's all done, but it will still need a center beam to fix the sag. In summary, overall it went smoothly. It took lots of planning and preparation work. To tear it down and replace it would have cost a bundle of new material and taken even more time. Post-move addendum, clearing some more trees. My process usually involves attaching a safety tow strap as high in the tree as possible to help guide it where I want it to fall. My felling preparations include pre-tensioning the tow straps with the come-alongs. Here the tree is estimated to be about 100 feet tall. I have 120 feet of tow straps. The cut involves a front hinge cut and a central through cut, which is supported by the wedges. With a quick back cut, and the tree is directed to the landing pad right over the original shed location. When I finished making this video, I realized there's no people in it. So, for human interest, here's a picture of myself.